All right, let's dive in. Today, we're going to pull back the curtain on one of the coolest tools in machine learning, the decision tree. It's the secret sauce behind how machines learn to make choices, and you'll see it's actually way more intuitive than it sounds. So, to really wrap our heads around this, let's start with a problem we can all understand. Every single year, universities get buried in applications. How on earth do they decide who gets in and who doesn't? You'd think it's this super complex thing, right? But really, it just boils down to a series of smaller decisions. I mean, picture an admissions officer, right? They've probably got this little mental checklist. First up, they glance at the GPA. Is it good enough? Okay. Next, they look at the test scores. After that, maybe they check for any special experience. And based on all that, they finally land in a decision: admit, decline, or maybe waitlist.
Okay, but here's the kicker. What if we could teach a computer to follow that exact same logic, to just look at an applicant's file and make a fair, consistent decision all by itself? Well, the answer is a huge yes.
So how do you actually build a machine that can decide? Well, it all comes down to a really cool tool that's designed for exactly this kind of problem.
And that tool is the decision tree. Honestly, the best way to think about it is like a map or maybe a really smart flowchart. It's basically a picture that shows you all the questions you need to ask to get from a messy pile of data to a single, clear answer. Now, decision trees fall under this big umbrella of what we call supervised learning. And don't let the name scare you. The supervisor is just the data itself. See, we give the machine a whole bunch of examples where we already know the right answer, like all those past admission decisions. The machine then studies them and starts to figure out the patterns on its own. Okay, so what does one of these trees actually look like? Let's break down the anatomy. It's surprisingly simple. So any decision tree you see is going to have three key parts. You always start at the top, at the root node. That's your very first question. Answering that question sends you down a path to an internal node, which is, you guessed it, another question. And you keep doing that until you finally hit a terminal node, which we also call a leaf. And that's it. That's your final answer. No more questions. All right, enough theory. Theory's great, but let's get our hands dirty and actually build one of these things using our university example. Okay, so first things first, we need some training data. Imagine this table of past applicants. We've got their GPA, their test score, and this is the most important part, the final decision that was made. And that decision column, that's the holy grail. That's the answer key our machine is going to learn from. So the first job of the algorithm is to look at all our data and ask, what's the single best question I can ask to split this group up into the purest possible piles? You know, computers use fancy math to figure this out, but for us, let's just say it decides the best first question is about GPA. And that question, that very first fork in the road, that becomes our root node. The tree is now going to take every single applicant and send them down one of two paths based on whether their GPA is higher than 3.55 or not. And check this out. That one question actually worked perfectly for one group. It turns out that every single person with a GPA of 3.55 or lower was put on the waitlist. We call that a pure node. Why? Because everyone in that bucket has the same outcome. So boom, we're done with that branch. That's a leaf. But the other side, the folks with the high GPAs, that's still a mixed bag, right? We've got admits and declines all jumbled together. It's not pure yet. So our tree isn't finished. It needs to keep growing. The algorithm looks at this smaller group and decides the next best question is about their test score. So we add another node with our next question. For just this group of high GPA applicants, is their test score over 900? This is going to split our remaining data one last time, and hopefully this will get us to our final answers. And bam! Just like that, our tree is done. 2 questions. That's all it took. Now every single path you can take through our little flowchart ends in a totally pure group, a clear final decision of admit, decline, or wait. Okay. Building the tree is cool and all, but this is where the magic really happens. Let's put our new tree to work and use it to make a prediction for a totally new applicant it's never seen before.
So, in walks a new applicant. We've never seen them before. They've got a GPA of 3.60 and a test score of 901. So, looking at our tree, where do you think they're going to land? Let's trace it out.
Okay, step 1, we start at the top, the root. Is their GPA of 3.6 higher than 3.55? Yep, so we head down the yes path. That takes us to our next question. Is their test score of 901 higher than 900? Yes, it is. So we follow that yes path to the very end. And we land right on a leaf node. And what does it say? Admit.
There's our prediction. It's a clear, totally automatic decision-making process that's based only on the patterns the tree found in the data. Pretty cool, right?
So obviously that was a super simple example, but these things are everywhere in the real world, from helping doctors diagnose diseases to figuring out which ads you see online. But like any tool, they're not perfect. They have their own strengths and weaknesses.
On the plus side, they're so easy to understand. You can literally just look at one and see the logic. But the big drawback is something called overfitting. It's kind of like a student who just memorizes the answers for one specific practice test. They might get a perfect score on that test, but if you give them a new test with slightly different questions, they completely fall apart because they never really learn the concepts.
And this, right here, really puts the scale into perspective. Our tree, we could draw it on a napkin. It had what, 3 nodes and used 2 features? A real-world tree? That's a different beast entirely. It could have hundreds of nodes, using dozens or even hundreds of features. In fact, some of the best models out there, called random forests, are basically just huge teams of hundreds of different trees all voting on the right answer. But the core logic? It's exactly the same as what we just built.
So there you have it. That's the basic idea behind how a machine can learn to make decisions from data. It's a super powerful concept that's running behind the scenes in so much of our world. And that kind of leaves us with a big question to chew on. Now that we understand how it works, which of our own human decisions are we ready to let a machine take over?